Hi students, today we are going to crack few MCQ questions from D and F block. It is from class 12 chemistry. Which of the following first row transition element is expected to have highest third ionization enthalpy? Whenever they talk about ionization energy, first we should write the electronic configuration. So iron is the 26th element, so it will have 3d6 configuration. Manganese 325, so it will have 3d5 4s2 configuration. For chromium it is the exceptional configuration, so it is actually 3d5 4s1. 3d5 4s1. And for vanadium it is argon 3d3 4s2. So now I want to remove, because they are asking third ionization energy, so I want to remove 3 electrons. So if I remove first electron, first and second electron, and d orbital, from d orbital I'll remove the third electron. So now the configuration goes to 3d5. And if I see the second question, if I remove the first electron and second electron, and if I want to touch the third electron, it is having 3d stable configuration, which is 3d5. So because of this reason, manganese will have the third ionization energy, because this 3d5 configuration is the half-filled configuration. Half-filled configuration. So if I want to remove any electron from the stable configurations like a half-filled and completely filled, I need enormous amount of energy. So according to this, manganese will be the correct answer, highest third ionization energy enthalpy. And for the next question, the most stable oxidation state of iron is. So again, for this, iron can exhibit oxidation number +2 and +3. Both are stable configuration, and we have to check which one is the stable configuration. So for this, iron configuration is 3d6 4s2, and if I remove 3 electron, and again it is reaching 3d5 configuration. So if I check 2 plus 2 and plus 3, 3 will be the most stable because it is gaining its half filled. Third question, the equilibrium Cr2O7 2- changing to chromate ion. So this is orange color crystals, and it is changing to yellow color in basic medium. The opposite can happen. This chromate will be changing to dichromate in acidic medium. So according to this question, this equilibrium can exist in basic medium. When MnO2 is fused with KOH in air, it gives K2MnO4. It is a direct question from NCERT. The product of oxidation of SO3 2- with MnO4- in acidic medium is, this SO3 2- will be converted into SO4 in acidic medium. Coming to the next question, the correct order for the increasing oxidizing power in 3D series of transition element is. So for this question, we have to find the oxidation state first. So Mn, I'm considering it X. For each oxygen, it is -2 charge, which is equal to -1. So X is equal to +7. And for chromium, it is 2x because 2 chromiums are there. And for 14 is equal to -2. So 2x is equal to 12, x is equal to 6. Oxidation state. For vanadium, it is x -4 is equal to +1. So x is equal to 5. Okay, so since this manganese is +7 configuration, it is the highest configuration, highest oxidation state. So highest oxidation state, so that will be the most, that will have the most oxidizing power. So according to this, option B and C will be coming. So after +7, chromium is +6, that is the maximum. For chromium, +6 is the maximum, and for vanadium it is +5 is the maximum. So according to this, so for Mn O4 should be the highest. After that, this chromium should come. So option C is the correct answer. Chromium followed by vanadium. Which of the following is diamagnetic in nature? Diamagnetic meaning magnetic property, or the electrons should be paired. Pairing can take place only with the help of strong field ligand. So option strong field ligand is it should be ligand should be strong field, and whether it is a octahedral complex. So this chromium CO argon 3d7 4s2 is the configuration, and I want in 3 plus state. So if I remove 3 electrons, it will go to 3d6. So 3d6 with the help of strong field ligand only will pair up the electrons. So all 6 electrons will be paired in 3 orbitals, and the other 2 orbitals will be empty. So according to this, so option A is the correct answer. CO3 plus octahedral complex with a strong field ligand can form diamagnetic compound. Which of the following does not show variable oxidation state? So according to this question, see, we have scandium, it can exhibit only plus 3 configuration. Mn plus 2 plus 3 plus 4 plus 5, 6 and 7. Copper plus 1 and plus 2. Iron plus 2 plus 3 plus 4 and plus 6. Okay, so according to this, which is not show variable oxidation state, so it is scandium with only one oxidation state. Transition elements form alloys easily because they have nearly the same atomic size. Because of the same atomic size, this alloy formation can take place. Which of the following element of 3D series of transition elements have lowest enthalpy of atomization? So A is atomization, enthalpy of atomization. So for this question, we have to write the electronic configuration first. So whenever we talk about atomization energy, we should check the number of unpaired electrons. So according to this question, they're asking the lowest. So in zinc, if you check, all the electrons are paired. There is no unpaired electron. No unpaired electrons. Since there is no unpaired electrons, and since all the electrons are paired and there is no unpaired electrons, the enthalpy of atomization is very, very less for zinc. From the following elements of 3D series given below, which element shows the maximum number of oxidation states? So for this, you can refer this. Mn can show the maximum number of oxidation state with 6 oxidation states. So Mn is the correct answer. Next question. The general electronic configuration of D block element is N-1 D N210 and NS1 to 2 is the general electronic configuration. Transition metals are known to make interstitial compounds. The formation of interstitial compounds makes the transition metals more hard. This is the answer. It is actually given in NCERT. Because of this character, the interstitial compounds form the more harder compounds. Out of Fe2 plus, CO2 plus, Cr3 plus and Ni2 plus, the one which shows highest magnetic momentum is. So whenever they talk about magnetic momentum, we should check the number of unpaired electrons. So if I check Fe2 plus configuration is 3d6, CO2 plus is 3d7, chromium 3 plus is 3d3, nickel 2 plus is 3d8. So when I arrange all these electrons in the d orbital, here I have 4 unpaired electrons. Here I have 3 unpaired electrons, and here also 3. And when the last example, I have 2 unpaired electrons. So as the number of unpaired electrons is more, out of this 4 is the maximum. So as the number of unpaired electron is more, the magnetic momentum is also going to be higher. So option A is the correct answer. The most common and stable oxidation states of lanthanoids are. So most common oxidation for lanthanoids is +3 configuration. Thank you.